It's 7 o'clock.
There we go.
All right. I think people will keep trickling in for a little bit here, but we'll record it for everybody else. Anyway, thanks for joining us tonight, everybody. So we have an astrophotography workshop here on using PixInsight to make beautiful astrophotos, and we're pretty fortunate in this club to have some really world-class astrophotographers within our midst, and one of the best is our own Wes Klehm. So we're going to hand it over to him, and if you have any questions as we go, feel free to chime in. Just holler or raise your hand in Zoom, whatever it takes, and this can be as interactive as you want it to be. So with no further ado, let me hand it over to Wes.
All right. Hey, everybody. My name is Wes, and I've been in the club for a little over a year now. And I started doing astrophotography about three and a half years ago, and doing PixInsight for about 3 years. And so I know it reasonably well. So hopefully, what I go through tonight can be helpful to you guys, and um, maybe give you a good starting point, because I know that PixInsight is a bit of a hairy thing to open up. So as you can see with PixInsight, when you open it for the first time, here it is. This is what you get, what you see. What a nice lack of tutorial you get. It just throws you into the wind and says go. So I like to think of PixInsight as it's a toolbox. It's just a pile of tools. It's like your toolbox, a wrench, a hammer, or whatever, but you don't have that instruction manual from IKEA to give you an idea of what you're supposed to do. So, when I first got started with it, I just Googled, found other people that posted their workflows and stuff like that. So hopefully what I'm going to do for you guys tonight is kind of provide my workflow and give you that starting point of what you're supposed to do. Um, so first off, when you first use PixInsight, you'll be stacking your images. And so I'm going to start with something called Weighted Batch Preprocessing. And you'll find that up here under Scripts, Batch Processing, Weighted Batch Preprocessing. This is where you're going to throw all of your raw files, your darks, your bias, your lights, and that's what's going to stack them. Think what a Deep Sky Stacker does for you, or if you're using Serial or AstroPixel Processor, one of those others. This stacks it, and it does a very good job. It's very detailed in what it does. So let's open that up, and it might take a second because I already loaded some data into it, so it might take a moment. Okay, cool. So when you first open it, it's going to start here. There's the bias tab. So when you have all of your data, if you're using a DSLR, you're probably going to be using bias frames. If you have a cooled cam, you're probably just going to be using darks and dark flats to do that calibration. So in order to add these, you can just click directory, and you can select the entire directory that it's in. So for the demo for the club here, I've just got these 4 folders. It's got my L frames, R, G, and B. This is nowhere near like the full project, but it's just for example. So you could just add this entire directory, and if your acquisition software marks the files appropriately, like this file is a flat, this file is a dark, this file is a bias, whatnot, uh, WBPP will automatically put it into the appropriate tabs here. If you're just using a DSLR, like manually or with an intervalometer or something like that, you'll have to do it manually using these. And if you click Add Bias, Add Darks, Flats, Lights, it will automatically put those into the tab they're supposed to go, because they're not otherwise labeled, but you know what they are, and so it trusts you and it'll put it where it's supposed to go. So in this case, I didn't take bias because I have a cooled Astrocam. I have my dark masters. If you have a cooled Astrocam, you probably have a dark library. If you don't, you should have one because it saves a lot of time. These masters I took back in like November, and depending on how good your camera is, you may only have to update these once every 6 months, once a year, something like that. Mine are still performing well, so I probably aren't going to update these for a little bit, but I should. We have enough cloudy nights to do so. The flats, these are my flats for R, G, and B, and L, and they all show up here. So I took 30 flats in this case, per filter per night. So if you're doing a multi-night project, it'll also group them accordingly, um, according to which night was which set of flats. So your flats will end up here. Here's my L flats, my R flats, G and B.
Hey, Wes, can I ask a question there? Like,
Yes.
so it automatically sorts those by date for you? Like, I never
So
could get that to work. Does that use grouping
here's
keywords
what
or?
yeah, that's a good question. Here's what I do. So my family is a big fan of Bluey, the kids show, and one of the names that they use when they're playing games and stuff is Diddums. So bear with me here. So I've just thrown the word Diddums into all of my folder names. Da 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 da. It's my default. All of my folders have that in it. You can then use that keyword over here in the group keyword groups and activate that, and it'll automatically group on everything after that keyword. So whatever that name is, it'll automatically group those for you. So
Oh,
Diddums 12/3/1950B, because that's the date and the number of frames and the filter ID, blue in this case. And so then all I have to do is drag the whole folder in here and it goes. It just automatically sorts everything for me. Uh, the only thing I have to do here is select the directory and then wait a minute or two for it to load all of the files. And it automatically does everything for me as far as sorting goes. So it's got my 60-second RGBs right here and the 30-second Ls all automatically sorted. And it also using that keyword, it connects up with the flats that are in the same folder. So you can see here, these are my March 19th Ls that I took. I include the flat folder in here as well so that it knows to connect those together.
okay. And what software are you using for image acquisition where it's enforcing that naming convention?
I use Nina for
Okay.
everything, but the ASI Air also does that as far as I know. Anything that's uh, like astronomy, astrophotography tool also does it. So most of the big names of big names of acquisition software do that. It'll label them appropriately in the metadata of the image.
Cool. Thank you. I learned something already.
Nice.
Cool.
Um, so here we have our Ls. So this is where we start setting up like what we actually want the pre-processing to do. So in our case, I use a mono camera, LRGB. So I don't want to use this first one, linear defects correction. I researched that actually because I didn't know what it was. And it has to do with old CCD cameras, which have an entire column of pixels that like can be bad. So in this case, we don't need to use that because I'm using a CMOS camera. Subframe weighting. We do want that one because that actually does the measurements and gives a weight to every image, so that like this one might be a little bit better than this one. So when it does the integration, the one with the higher score gets averaged in at a higher value. So let's say you uh, took some images on a slightly cloudy night. Well, those, or maybe your guiding wasn't super good that night. Those would get like just a little bit lower of a weight than the ones that you were on like a really good night. So that's a good way for WBPP to assign those values and know which images were really good and which aren't super good. And then also if if the score is too low, it'll actually even toss those. It won't even include them. Let's say you had a plane go through and it wasn't any good. Where I live under the landing strip for the Orlando airport, and every now and then I have a big plane streak go across. Um, Satellite trails, asteroids, things like that are just a little squiggly line. The software can handle that. It can remove those. It'll average those out. But when a plane goes through, there's nothing it can do, and those often just get tossed. Um, Image registration. That is where you actually have each image aligned. So, you have this one, you have this one, and they're just a little bit off. The stars aren't perfectly aligned. Maybe you dithered, maybe your tracking is a little weird, something like that. It's never gonna be perfect out of the box. So image registration aligns the stars in every single image across all of the images that you took. So it has to do that before we can go any farther because the stars have to be aligned. The settings within these, I largely leave as default. I don't think I mess with these at all. I did change on subframe weighting, I did change this to PSF scale SNR, not because I thought that was the best, but because I looked that up and a couple of like astrophotographers I follow, Adam Block, he recommended doing that. So if it's good enough for him, it was good enough for me, and it seems to be working for me. Astrometric solution, that'll actually like plate solve every single image. You don't really need to do that, so I leave that off. That just adds an extra step and time to the stacking process. Local normalization. You do want this one on, especially if you've done stuff on like multi-night imaging where the skies were like inconsistently bright, or maybe a little bit of clouds going through, various different things that can cause some images to be brighter or darker, and this will normalize how bright the images are. Because when you get to the next part, you want each image to more or less be like a similar brightness, so that the brighter ones don't overtake the less bright ones. Because usually if it's less bright, you actually have better data because, you know, less clouds, less light pollution, that sort of thing. The signal, the actual photons from the thing you're trying to image is more present there than the more light polluted ones. So that's why we want this one. And I believe I didn't really mess with this at all. I think the settings are all default there. And then finally, we have image integration. That's the end all be all we get here, and it actually averages all of the images together that you took to remove the noise and actually bring out the image of the object that you're trying to get a good shot of. I don't believe I mess with these too much. I may have adjusted one of these, like that one. But again, I think I adjusted that because Adam Block said to do it, and again, that was good enough for me. So that's pretty much it on these. Let's go over to now the calibration tab. So here's where it sort of summarizes all of the images that you have loaded into WBPP. Here I have all of my darks, here I have all of my flats, and here I have all of my lights. Again, the lights are the actual images of the thing you're trying to take a picture of, actual shots of space. Here's where you can sort of verify that, like, okay, hey, these L frames are using darks and they're using the flats. You want to see the check boxes here. Or if you're using bias, you also want to see the check bias here, the check boxes here. So just to make sure, this is like a double check to make sure that everything is aligned properly and everything is being used correctly. You want to make sure your flats and your darks all line up. And you can see here, I've clicked on this one, and it's using these flats and it's using these darks. It'll highlight those. So each one has their own thing. It'll highlight that. Same with the flats. If you want to check those too, I'm using dark flats in this case, or flat darks, whichever you want to call it these days. These flats use these darks and so forth. One thing too that's not super intuitive that really helps, especially if you have an older camera, a very noisy camera, DSLRs especially, but also Astrocams also have this, are hot pixels, where you'll have little white pixels throughout each frame. I believe they're somewhat random, but some of them are consistent. It's like it could happen from cosmic rays hitting it too. So you'll have these like white pixels in the frame. And so you want to use something called cosmetic correction. And I'll show you that in a little bit after I close this, how we set that up. But by default, it's set to none. When you'll have to create this on out on your like PixInsight desktop, if you want to call it that, and select that and apply it to all light frames, because that's an extra step in the process to remove those white pixels that would otherwise be just annoying during the integration. So it cleans those up before actually getting to registration and then integration. I can go into that in more detail if anybody has any questions, but I'll show that process to you in a little bit. It's really easy to set up. You just drag it out there And then once you have that there, it's selectable here. This one here, CFA settings, that has to do with if you're using a one-shot color or a DSLR. If it's a color camera, you'll need to do stuff with this that has to do with like the bare matrix of your camera. I'm not super familiar with that because I've been doing mono pretty much the whole time. I have very limited experience with doing color cam. So I've not really messed with this. Maybe when Frank or John Starr or whoever else decides to do a presentation on um, how they do their stuff in PixInsight, maybe they'll touch on that since I don't have any experience with it. Okay, post calibration. Let's move on to this tab. This is the summary of what you're going to end up with if everything goes right at the end of stacking. You're going to end up with that many minutes of this one, that many minutes of that one, blah, blah, blah. It gives you an idea of what you're going to be left with. Again, this is not a full project, so mine are usually more like 3, 3, 3, and then like 9 to 14 hours for these. But you can see here, this is just a quick summary of what you're going to end up with. Pipeline. This is what you're going to see when you click run. It's going to pop up a window like this, and it's just going to start banging through all of these things, you know, do. And it might take, depending on the size of your files and how many files you have, it might take 10, 20, 30 minutes, or in my case, my last project I did, I think it took about 17 hours to finish up because I had roughly, I think 1,400 L frames because I do 30-second shots because of the light pollution here. So it can sometimes take a while. And that's pretty much it for the pipeline. This is what you'll see when you're waiting. I often recommend people that if you have a lot of files, start this right before you go to bed and then wake up in the morning and you have your masters done. All these things over here, other than the groups thing that Frank pointed out, I largely left this as default. And this is the output directory. That's where you select where stuff is going to go. I have this set to my one of my internal SSD drives because those are very fast. You want to, if you can, if it's possible, you want to be running this off of an SSD because the file input output is often and it's fast, and you want it to go as fast as possible. So once you've clicked run and you've waited anywhere from 10 minutes to 3 days, or however it ends up being, you are going to be left with some master files. So let's go ahead and I'm going to move over to my other workspace where I have everything prepped. So these are the master files you're going to end up with. And the first thing you're going to say is, well, that doesn't look like anything. Well, when you stack your images, it's going to look like this because it's a very, very dark object, and there's just not a whole lot to see before you do something called stretching, and we'll get to that. But PixInsight has a nice tool to be able to show you what's actually there without actually stretching it yet. It's called the screen transfer function. You can do that once you have your mostly black image here that's fresh out of stacking. You can click this little icon up here. It's like a little computer monitor with a radiation symbol on it. You click that and boom, there we have it. This is our freshly stretched, freshly stacked image of M109. And not too bad, given that almost all of my data that I collected for this was during 90% moon or greater. So a lot of what you see here, this like big gradient you see across here, say thank you to our moon. One little neat thing you might notice here is that there are some fuzzy reflecty things going on here. I don't know if you can see that through Zoom, but that is due to the star Phecta, which is in, if I pronounced that right, it's in Ursa Major. It's in like the bottom of the cup of the Big Dipper, and it's like over here somewhere. If this was a bigger frame, it'd be about here. And so we've got some like starlight coming over here, contributing to our image here. So we have all these. Here's my blue frame. Here's the green frame, and here is the red frame. Red looks pretty good. Green has quite a bit of light pollution gradient going on here, as does my blue. I believe as I worked on this, I got a little bit better at taking my flats because I was still learning the optimum exposure time for my flats. So the R has a lot less vignetting left over in it than like the blue and the green does. But so now that we have those are our masters. The first thing we want to do, if you'll notice in the edges and in the corners, you'll have some weird pixely noise going on. See here, like the noise here is not nearly as bad as the noise along the bottom edge here. That happens from the registration. You remember how the stars are aligned. Each image is a little bit different. You know, no mount is perfect, except if unless it's like an astrophysics or something. Um, no mount is perfect, so there's gonna be some variation, especially if you're dithering, which you should be. Um, there's going to be edges along there that need to be lopped off. So the first thing we do is we use dynamic crop. It's a little tool that you can use to just like lop off edges. And I just keep these on my PixInsight desktop that lop off 50 pixels, 100 pixels, and 200 pixels. Sort of depends on how far off or how much dithering or how weird the image ended up being. But in this case, I lopped off 200 pixels and I just, so you just drag that onto here and it cuts that off for you. So now that we've cropped everything, so we have our cropped images, you know, here's L, here's R, here's G and B. You don't need to see all of them. So now that we have our cropped image, next thing we need to do something about is the gradient. So that's where GraxPert comes in. I'm not going to open up GraxPert because sometimes that takes a while to open, but that is a third-party program that you download and install, and then you download in resources here, you have to add a resource, which I'm going to provide those to you like on groups.io or something. But what that'll do is that will install this script, GraxPert. It's a little script that will call out to GraxPert externally and run that on this image. And you just select the image that you want to run that on, and you'll use subtraction and the level of smoothing. I almost always use 1.0 because if you use less than that, sometimes the gradients can get a little weird. So I usually just run it with 1, and that usually does a perfectly fine job. And what that will do, it'll yield something like this. As you can see, remove the gradients a lot. It's a lot more flat. It's a pretty even background across the whole thing. We have this area here is, for the most part, about the same brightness as what's over here, rather than like, you know, this is much darker here and much lighter here. And here is the gradient that it removed. So it actually it subtracts the value of this image here from this one and yields this one, which is the type of image that we can now work with.
Excuse me,
So,
Wes.
yes.
Um, could you walk us through kind of the weird UI of PixInsight, like what the check mark and the X and the little diamond thing does?
You mean like along the top here of the images?
No, like from the GraxPert script or the cropping process, for example.
Oh, yeah, okay. Sure. So So this is a PixInsight process, dynamic crop, and most processes, any tool that you're going to use here, most of them have something like this. And you're going to have this little triangle, you're going to have a check mark, and you're going to have an X. And the X is cancel. You end up canceling this. The check mark means basically execute or go. And also there's this triangle, which you can actually use to drag onto something, and it more or less does the same thing as like the checkbox, but you can use it to apply it to other things. It doesn't have to be the one that's open, but you can do it to several different ones. That's more evident in something like, let's say, curves transformation. You take this triangle and you may have been messing with this one, but let's say you have these two open, you can just drag that onto there and that onto there, and it applies this process to each of those others.
Thanks. Yeah, the PixInsight UI is completely strange to
It's
anyone who hasn't seen it
super
before.
weird.
So
So I should have led with that. I apologize. So if you have a process open and you started messing with things like, boop, 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 you add a whole bunch of things, you can also completely reset the process back to default by pressing this little button down here in the corner, and you're back to square one. It's this one over here, it says reset. The tooltips in PixInsight are actually fairly useful. You can hover over anything and it'll mostly tell you what's going on. Did that answer your question, Frank?
yeah, thank you. I just wanted to call out how, there's no OK button, there's no cancel button, there's just
Yeah,
little shapes,
yeah.
and you have to know what they mean.
hmm So, okay. So now that we have our images with the gradient removed, we have these flat images. We're ready to start doing stuff with them. We fixed them up. They're mostly clean. Gradient's largely been removed. We're ready to go. So the first thing we want to do is linear fit. It's this process here. It doesn't look like much, but it's pretty powerful, especially when working with mono. Your camera and the light pollution in your area will cause your red, your green, and your blue to actually have slightly different brightnesses to them. Most cameras are more sensitive in the green channel than the red and the blue. So a lot of the time, your green channel ends up being just a little bit brighter. If I were to combine these together into an RGB image now, it might look really green or look really red because one was more powerful than the other when you just combine them right out of the box like this. So that's what linear fit is for. You usually pick the one with like the least amount of noise, and usually for me it's the red. And so you select the well, I have a huge list here because I have so many files open, but if you're just doing it, you would select the red image from that, leave these as default, and you would drag this onto the G and onto the B so that R and G and B are all this roughly the same amount of brightness. So it sort of it doesn't normalize it, but it brings them more in line so that when you combine them, they look correct. So once you've done that, you have whoops. Once you've done that, you have the linear fit images that like this. So it looks like I have R and B. So what I did was I linear fit to G. So they look the same. They don't look any different, do they? It just adjusted the brightness so that we can start working with them. Okay, that's linear fit. Now that they've been linear fit, we're ready to put them together. We use RGB combine, channel combination. It's up here. Oh, one thing to mention, most of these tools, all of these tools, they're not just, as you saw before when I showed you this, they're not here. I have all of these saved to my desktop in a process file that I've saved. For you, by default, they're going to be up here under processes in all processes. So we have like channel combine, channel combination here, linear fit was here. It's in alphabetical order if you do all processes. So they're all in there, and that's where you'll find them. If you don't have a saved process desktop like I do. So now we're ready to do the channel combination, and here's where you would select your R channel, your G channel, and your B channel. And so in my case, it would be the original G and this R and this B because I linear fit these two. And that will yield our RGB file here. Not bad. It's pretty green, as is usual for me because of the light pollution here. So once you have these combined together, it doesn't look very good because of the green. I believe Doug Woods always complained about his images looking really green, and now here's where we try to fix that up. So the next step, once you've combined these together, you use the image solver. I just put a random thing here to as like a placeholder, but it's up here in scripts under image analysis, image solver. You would use this script here and enter some information about the object you're taking a picture of. It might already be there if your software, like Nina or the ASI Air, it might already be there if it put it in the metadata of the image, but it might not. So you might have to search for your object and find it in here. In this case, M109, you search that and click OK, and it'll fill in that data there. You might have to enter the date and time of your, generally speaking, of when you took your images. It doesn't have to be exact. It just has to be more or less the right year, really. And that's because, stars move and when it solves, it has to know roughly the time period because the year 2000 and the year 2024 stars have really moved for this tool in that amount of time. And then a little bit of information about your scope and like the pixel size from your camera and blah, blah, blah. It will image solve your thing, and it won't look any different because it adds the metadata for the next tool to use. So the next thing we're going to do is do color calibration. Spectrophotometric color calibration. That's a mouthful, I know. But in this case, it sort of color balances the image that we had before. So it'll take it from this greenish state to something a little better. So out of the box, I think I had to select the camera that I've got. So in my case, I have the Player One Poseidon, and that is a Sony IMX 571. So I've got that selected there. And then the filters I used are here in the dropdown. There's a ton of filters in here you can choose from if that's what you're using, and mine were in there, fortunately. So I was able to select those. Um, there's a You then use the Gaia database, which that's a whole nother thing. I can talk about that maybe on groups.io about one of the things you have to download in order for this to work right. But once you've got that set up, then you can use Gaia here, and that's got the photometric analysis of like millions of stars that it knows what they're like, what color they're supposed to be, to help guide this color calibration tool in producing color balancing your image. And then once it's image solved, once you've got that done and you've got this set up, you drag that onto that, and you're left with a color calibrated image, which will look a little better, a lot less green. It may even have some blue in the arms of the galaxies. The stars will look a little bit better. Like, we've got a red star there and other red stars, a couple blue ones in there. These like little background fuzzies, they've turned blue now. So that's much better. We're in a much better direction color-wise. All right, so now you've probably heard us, once this is color calibrated, before you really do anything else, the next thing you've probably heard us talk about before in various meetings is something called BlurXTerminator. And sometimes it almost feels like cheating, but then once you use it and once you learn a little bit about it, you realize like, oh no, it's awesome. So we've got BlurXTerminator here, a very simple looking tool, but super powerful. It's just really the best. It made a process called deconvolution. It took it from a really difficult to grasp and difficult to execute well process and made it into a few sliders, and it's just awesome. So by default, I think these are set to 0.5 and 0. For your images, the pixel scale of your images, it may vary what looks best for you. In my case, I like to sharpen my stars at about 0.2, 0.19, and I like to remove the halos at about negative 0.09. This will tighten up your stars, and the star halos, if you have halos, it'll just bring those in a little bit. Essentially, it reduces the size of your stars just a little bit, and then sort of using that information, it will also sharpen the entire image. What this sort of does is it figures out how blurry, how big your stars are compared to the point of light they're supposed to be, runs sort of a reverse uh, deconvolution on it to tighten up the details of everything else in the image. While it tightens up that star into a slightly smaller star, that same process is run on all of the other information in the image. So you'll end up with a sharper, clearer image. So let's go ahead and open up what that made it look like, and I'll sort of show you the difference. So here's a zoom in of our galaxy here, and there's the after. As you can see, like the little bits of the nebulosity, the nebulosity that's seen in the arms there, that's a little bit tighter. It's a little bit brighter. The stars are a little bit more under control. If you had any sort of tracking errors or any sort of back focus issue where stars were a little bit streaky, not quite round, BlurXTerminator cleans that up too. Um, and it cleans it up across the image in little tiles. So if ones are streaky, like a back focus issue, if you had stars streaky out from the center, they're not all pointed the same direction. They're all pointed out from center. BlurXTerminator can still help with that because it looks at individual little chunks to figure out what the stars are doing in each one and fix them accordingly, like in a per area basis. So it's
Wes,
it's really fantastic. Yes.
um, BlurXTerminator and one other, when they did an upgrade, I think this year,
Yep.
caused problems where you couldn't use them or you had to pay extra. Is BlurXTerminator one of them? Where you have to have additional coin?
BlurXTerminator is an extra cost tool from a guy named I think his name is Russell Croman. And the RC tools. So you've got BlurXTerminator, NoiseXTerminator, StarXTerminator, and those are all extra. I think all together they're like what about 210 bucks, something like that.
More
So
than I paid for
yeah,
PixInsight.
yeah. Here's something. Thank you for bringing this up. This was something I forgot to mention right when I started. Um, I don't know if anybody else is like me, but like on your phone, you have an app that is 99 cents, and I'm just like, I'm not going to spend 99 cents on that. It better be free. And so a lot of the times I feel like people that are getting into astrophotography, they're spending, $1,000 on a scope, $1,000 on a mount, and $1,000 on a camera. They put together, three, five, $10,000 on all this gear. And then they go to process it, and they're not thinking of the software as another piece of gear. You're going to get more out of some of these tools than you will out of the free tools, and it's going to do more for you than, spending $5,000 more on an even better telescope, right? Like this is think of the software as an essential part of your gear. And I've seen some amazing things done with like Serial and AstroPixel Processor and GIMP and Photoshop. It's not like it can't be done with like the free tools, the tools that we already have. But in my experience, PixInsight is pretty much the best one. It's a one-time purchase of 200 and something dollars, and I think they haven't upgraded it yet, but they did say that when you go to upgrade to 2.0 or whenever they decide to do that, there will be an upgrade cost. But as of now, I haven't seen it's been 200 and some dollars for the past several years. I haven't had to pay extra to continue using PixInsight. They've added incremental updates that have fixed certain things, bug fixes, and they've definitely improved it all on the same amount that I spent 3 years ago. Same idea with Russell Croman's stuff, the BlurXTerminator, NoiseXTerminator, StarXTerminator. Those are tools that are just going to elevate your image to the next level. BlurXTerminator in particular adds a level of sharpness to it that's like adding, an extra several inches of aperture, and it really it does an amazing job of adding the sharp, like fixing some of the sharpness that you've missed out on due to a various different things. Maybe your back focus wasn't right, maybe your guiding wasn't perfect, because whose ever is. So it really does a great job, and I highly recommend adding that to your toolbox. So yeah, it does cost money. I believe BlurXTerminator is like $90, but it's worth it. when you compare what it adds to your images compared to trying to get a better mount or a better guide camera or a better camera. Like it's a really great tool, and uh, I speak very highly about it. I actually watched the explainer video from Russell Croman about how BlurXTerminator doesn't make up data. That was another concern people had when BlurXTerminator came out. They're like, oh, it's like topaz denoise. It like, does a thing and it sort of makes up information and adds that in there because one of the things that he announced was that it was trained on Hubble data. Well, that triggers a thing thinking that like, oh, is that looking at Hubble data, knowing what this is supposed to look like and adding data? Well, no, it's not. It's just trained on that to know what to do with images that look like that. So stars that look like that, nebulosity that looks like that. So it's not making up data. What it's just doing a lot of math. A lot of mathematics go into what BlurXTerminator is doing, and that's why I didn't run it. I'm not usually running these tools for you live here because depending on your computer, BlurXTerminator can take a couple minutes or even longer. So it's a great tool that doesn't make up data. It just brings out the best in your image. So that's my spiel on BlurXTerminator and why it's great. So thank you for coming to my TED Talk.
Yes, I
So
agree. A quick question though on the settings there. So is the slider for sharpness actually kind of backwards? Like if you turn down the sharpness, does it make it more sharp? Is that right?
Yeah,
Or do you
for
think people?
stars,
Yeah.
I believe it's the more you move it this way, more to the right, the smaller it tries to make them.
Okay.
And so I think it's that slider, the optimal thing sort of depends probably on your pixel scale. So I believe when I was using my 400 millimeter, I think I was more in like the 0.25 to 0.35 range. That's where I found my stars looked the best without getting really too small or weird looking.
Okay.
So that may be a slider that when you run it on your stuff, it varies. So when I know you use this, Frank, and so you might not use 0.19, you maybe use something a little bit different. I think it depends a lot on uh, the kind of data that you're getting from your system, the camera plus telescope.
Mhm.
Also taste, like some people like a lot smaller stars. Some people don't care how big the stars are. Some people love the stars. I mean, star clusters. I that's another thing. When I run this on a star cluster, if I've done a star cluster, I don't run it as high. I think I move it a little bit lower because the stars in the star cluster are the star of the image, so I don't shrink them as much.
Cool. Thank you. And you just like get that through trial and error? Like, is there a process
Yeah,
to finding the right value for you?
yeah. I have a preview here. In this case, I ran this on a preview. You can press Alt in and select like a small chunk of sky here. Splits a little box and brings a preview window up here.
Mhm.
And so this is just a small chunk of your image, and you can run any process in PixInsight on this preview window. So in this case, you can run BlurXTerminator on this, and it doesn't take, an hour to run. It might take 10 seconds to run it on this little thing, and you can sort of inspect where it optimally is. So in this case, usually on a galaxy, I've included the galaxy in my preview that I'm playing with, and I drag and drop, and see what ends up looking best. I really pixel peep in there to see
Mhm.
what ends up looking best. And this is usually what I settle on is values around this much on my pixel scale.
Cool.
Wes, have you taken files from people who use the C star and saved the individual pictures?
Just a couple times. John Pinto gave me some data on the Sculptor Galaxy, and I think it was the Helix Nebula. And I played around with those in here, and BlurXTerminator did help those a fair bit because the C star is an alt-as mount, and so sometimes the stars get a little weird in the corners. You have field rotation, and so sometimes the stars are just a little bit streaky out in the corners. It's hard to see, and when he originally gave it to me, I think they were 10-second exposures, and so those stars actually looked fine. But I haven't seen the ones now that I think they increased it to a 30-second exposure, or at least
It's always been 10, 20, and 30.
okay. When he first gave that data to me, 10 was the only option. So, with the 30-second exposures, I would think that the corners corner stars would have a little bit of streakiness to it from field rotation. In any case, whether the stars look okay or they're a little streaky in the corners, BlurXTerminator fixes those pretty well. So
Do you
it
think
just
it's
does a.
worth doing with C-star pictures, or we
That's
should?
a matter of value to you. Do you like you
Okay.
have your if it's worth the $250 to buy PixInsight and then the
Oh,
$90?
I already have PixInsight.
Okay, well then, um, it all depends on whether you want to do it or not. It definitely improves them. It definitely does. I think back months ago when John shared that with me, he posted what the C Star app did automatically, and then I did my full process on that stack and posted mine, and it looked in my opinion, it looked a fair bit better. Definitely more detail in the nebulosity of the helix, and definitely more detail on the sculptor. So it'll definitely improve them. Whether that is worth $90 to you, I can't really answer. It's definitely worth it to me because I really love this hobby, if you can't tell. And so I've anything that improves what I'm able to produce, I go after. And BlurXTerminator for me is a no-brainer. For you, I can't answer that for you other than say it will improve them.
Just to chime in on the magic of
What?
BlurXTerminator. Like when you see my narrowbound images, those are 5-minute unguided exposures, and out of the camera, like out of the stacking, they're like terrible. Like the stars just look like footballs, right? But BlurXTerminator just makes them to nice little points, cleans everything up. It's just absolute magic. So well worth the money.
I think.
Yeah, I mean,
Oh, go ahead.
Oh, I was gonna ask. Sorry, I joined late, Wesley. What did you take the photo with? Like, what was the telescope mount? Camera?
This is with a Celestron Edge HD 8-inch on an EQ6R Pro mount with the Player One Poseidon M. It's the monochrome version of it, using 2-inch filters in the Player One Phoenix filter wheel. And all of that is controlled by Nina.
Are any of these tools like BlurXTerminator, are they any good for any of the planetary stuff at all?
That's a good question. When we did the Intro to Astrophotography class back in, what was it, February, I think it was. I actually, just on a whim, I brought up one of the images of the moon here in PixInsight, and I ran BlurXTerminator on it. It sharpened it surprisingly well, considering there were no stars. My understanding of BlurXTerminator is that it needs the stars to establish the PSF, the how the light has spread from the single point, the point spread function. But a shot of the moon doesn't have that, and it still sharpened it pretty well. I actually quite liked the result, and so I would say it's worth a try. You can definitely take your image of Saturn or Jupiter or whatever and run it on there and compare it to the same result from like Registax or something like that and see how the sharpening tool works. And I rather liked how BlurXTerminator worked on the moon. And
Yeah, you seem to like BlurXTerminator. I don't know.
I'm a fan. What can
Mixed
I
on
say?
it there.
It's awesome. Frank is too. Once you start using it, you can't go back. What can I say?
yeah, I did try it on Jupiter once, and it did a decent job. Like not as good as Registax, but it was close and a lot easier. So
Yeah, if you don't know how to use Registax otherwise, if you don't have to like mess with any of that, BlurXTerminator is an easy drag and drop, right?
Yep. Thanks.
So, all right, we've got our color image here, and we've exterminated the blur. So next thing we need to do is reduce the noise. You can see all that noise here, especially in the color data. The noise is going to look rather nasty, especially if you have a lower integration time. This one here is 534 minutes, which is what, about 9 hours or so, just short of 9 hours. So we want to reduce the noise. Well, thanks to Russell Croman, big fan of the tools there, we have NoiseXTerminator. And again, all we have here are draggable. How much do you want to reduce the noise? And in this case, I think I did 60, a power of 60 on it. And again, I use the preview window. This is where I sort of preview it. I zoom in on like the edge of the galaxy along with some of the background, and I try the different powers. I run, usually it's 40, 50, 60, and 80. I have heard that if you run it at 100, it can cause weird things. So I wouldn't recommend ever really running it at the 1.0 power. Usually I run things at 0.6 on my ASI 294. I was usually running things at 0.8 because that's a noisier camera than the Poseidon. The Poseidon is a better camera, so most of the time 0.6, 0.5 to 0.6, somewhere one of those usually brings the noise down to a good level. So I'll show you the noise difference from using NoiseXTerminator. As you can see here, it does a really good job of just smoothing out that noise while not harming what's actually there. Like you can see the galaxy a lot more clearly, like reducing that noise in a very controlled, nice way. NoiseXTerminator is also just really good. One of the other points I didn't bring up about PixInsight is if there is something you can do in PixInsight, like noise reduction, it's not one tool. There are like 7 tools you can use to reduce noise. NoiseXTerminator is the one I like to use because it's easy. It's just the slider that you move around and see which one works the best. But there are loads of a thing. Noise reduction. So here you go. Boom, 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 boom. I'm not going to go into all these tools, but there are ways to use all of them to reduce noise in your image. And NoiseXTerminator is by far the easiest, and I think it does a really good job. So it's the one I use, and I think it's what Frank uses too, and
Yep.
It's cool.
Do you choose a different setting for RGB versus luminance, or do you treat them
It
the
all
same?
depends on the level of noise. So like on my L's, my luminance frame usually has less noise because it has a lot more integration time, right? So like my luminance has 738 minutes all by itself, which is like 12 hours or so. Whereas this one is 9 hours, and it's only 3 hours per channel. So the noise is going to be quite a bit higher in RGB versus L. So yeah, I usually end up having to, I might run it at 0.4, 0.5 on the L, or 0.6 or 0.7 on the RGB. It sort of depends on the integration time too. So like, that's why I do these preview things, and I just figure out like which one looks the best. Because you don't want to overdo it. You don't want to hit it with like something too high that starts actually smoothing out these pixels, because you want to leave that fine grain noise. You want to leave just a little bit of noise because we haven't stretched yet. And if you smooth it out too much at this point, then you might end up with like a flat color across that doesn't look good in the end. Like it's one of those things. This is a place where you can sort of like mess up and not know it until you get like much farther along in the process.
Makes sense. Thank you.
So NoiseXTerminator, awesome thing. So we've exterminated our noise. It's really quite smooth across the way. We've left a little bit of noise. It's not gone. We still have that fine grain touch to it. So it still looks and feels pretty good, especially considering its color. And this was during full moon and whatnot. So here, now that we have the noise reduced and it's the color image, I noticed that there was a little bit of green going on the outside here. Again, that's largely due to moon and light pollution and the extra sensitivity of the camera in the green area. It's less so that one. It's mostly the moon and the light pollution though. So we use something called SCNR. And basically what this thing does is it sort of kills the green. If you have like a green tinged the whole thing, we can run it at various powers. You don't usually want to run it full green unless you're really bad off with green. So I usually run it around 0.5 to 0.6. In this case, because the moon was full, it has quite a bit of green in this outside area. And so this just let's see, is that the right one? I think it was. Yeah. So this just removed some of that green tinge that was out here. A little bit cleaner of an image, less green. because there really is not a whole lot green about out in space. Like if something is green, I think Charles Bracken during the talk last week mentioned that like, you know, if you have green, there are ways to get rid of it. So now that I've removed the green, I then make a mask, which sort of looks like this. To make the mask, you strip the luminance out of your color image, which you do that by clicking up here, extract CIE-L star component. That just lifts the black and white image off of your thing. So that's just the black and white of my color image here. You take that and you use a little tool called delinear on it, and that automatically makes it from a completely black image because this mask isn't stretched yet, and you bring it up to about this brightness. And then you use a curves transformation to just obliterate the brights and obliterate the darks, and it leaves you with a nice mask. And you can then apply the mask to this. Photoshop users should be used to using masks. It's the same sort of idea here in PixInsight. So you hit Control M or the mask thing up here and can select the mask, in which case there's like a ton here. So I don't even remember which one it is. But once you select that, that'll leave this highlighted because it's the white part is what we want to see. And then I increased the saturation a little bit to just bring out some of that color before stretching, because sometimes stretching can sort of kill the color in your RGB image. And so I just do a mild stretch of the saturation before stretching, just to bring out some of that color in the core, just a little bit. You don't want to overdo it at this point because you haven't stretched yet, but if you add just a little bit of saturation here, it can help maintain that once you do your stretch, because that's coming soon. So we have our saturated, slightly saturated image, and now we come to the last Russell Croman tool that I'm going to talk about how great it is. We have StarXTerminator. StarXTerminator does a really, really cool thing. And once you get into image processing and have messed with it for a little bit, like start creating some images, you're quickly, at least in my case, I quickly saw how big of a problem stars could be if you don't control them correctly. And if the stars are present in your image from start to finish, most of the time your stars end up being a little bit too big for your taste. At least in my case, I didn't like how big the stars were, how bright the stars were. They always just overwhelmed the target I'm trying to take a picture of. StarXTerminator removes the stars into a separate image and the object, the background, into a separate image, and you can work on those separately. And once you get to a certain level in image processing, it's just magical. Again, it's one of those things that it really opens up what you're able to do. You can completely control how bright your stars are. If you want your stars really bright, you can do that. If you want them sort of smaller, sort of dim, if you have like a big nebula you're working on, you can keep them smaller. But I'll get to the star processing a little bit later. So all you really have to do is open up StarXTerminator here. You want to leave this check, generate star image, because we want the stars. We want to have them over here. We want to have the starless image and the star image separately so that we can work on them separately. And you leave these other two unchecked. I don't remember what these other two do, but leave them unchecked. And so you run that on this, and again, this is going to be one of those processes that might take a couple minutes on your computer, depends on how fast it is. And that's going to yield a starless image that removes the stars. And over here I have the stars that it removed. So it lifts the stars right off and makes a separate file that has the stars in it. They look a little weird, but that's okay. Like, you don't have to worry about how weird they look in this stretched part, because when you add them back together later on, it's seamless. So for the stars image, I'm going to put them over here. I've set the stars over here. We're going to put them aside and deal with them later. Right now, we have our starless image. We have this nice little image of M109 and its friends, and you can see some of these background fuzzies a little bit better. And we're good to go. We're ready to start stretching because we want to stretch the object differently than we do the stars, and that's why we do that. So the next like several steps involve different ways to stretch the image, because remember, we've got our image here. It's still black. If you take away that screen transfer function, if you take away what we've decided to display this as, it's still black. All of the values of all of the pixels are still next to 0. That's why we stretch. So I like to use something called Generalized Hyperbolic Stretch because it's a mouthful and it's great. Again, this is one of those ones where there are 27 different ways in PixInsight to stretch your image. There's mask stretch, arcsine stretch, histogram transformation. There's there's just so many ways to do it. And I usually just start with generalized hyperbolic stretch. I believe this was one of those ones that I had to actually download as a resource. Again, I'll include that in the list of resources I use on groups.io. So this is it's sort of, I'm not going to go into the detail of how this process works because there are dedicated YouTube videos of how to use it. But generally speaking, you sort of like pick a spot here, you click send to SP, and then you select your local intensity. So I do this in stages. So I pick a number here, this local intensity around 9, and then you can use this circle to bring up a preview window, and then you can sort of play. The stretch factor is how much it's stretching. So here, the more I drag that over, the more, I don't know why it's not showing up. It should be showing up. Why isn't it? Well, it's supposed to. I'm not sure why. Well, anyway. So this is what I actually did to it with those settings. Okay, there you go. Now it's displaying. So with these settings of around 9 and a stretch factor of around 5, 4.9 or so, it's just starting to peek through. And that's my first stretch. I do it in stages so that I don't stretch anything too much, because sometimes you might blow out the core of a galaxy or a bright nebulosity, or you might like make the background entirely too bright. So I do just a soft stretch as my first step. So that leaves us with this. So then once I've done that, I bring up histogram transformation. This is another one of those things you can use to stretch, or in this case, BB step 12A. Here we go. So this is the actual histogram of this image here. And as you can see, the peak, all this space around here, this peak is not over here towards the edge. We want to move this over because that expands our the HDR, the dynamic range of the image, because all of this space here on our histogram is wasted because it's just black pixels more or less. So I have moved in the black point from here to a little bit over here. So this is what it looks like before, and up here is what it'll look like after. I've just moved that over. I've expanded the dynamic range. It's not a big effect, but what that does is darkens this background to a bit blacker. As you can see here, it's a little lighter, now a little darker. Okay. Now that we've moved the black point, now we have a darker background. We've removed some of the, like a lot of the black pixels, especially in the corners if you have vignetting. Those will end up being a lot darker. I do another stretch using the generalized hyperbolic stretch. And this time I do it at about 5. I do 9, 5, and then 3, and then sometimes I do 1, sometimes I do curves. And in this case, I stopped at 3. So this was my 5. I stretched it a little bit right here. You play with that, but that looked good to me. And so I stopped there. This is a multi-step process of stretching. Sometimes people just stretch it until they can see it, and that's fine. But I try to do like a soft touch, a little bit at a time, and it works for me. So again, and that's what it's going to look like after we run it at this power. So this is now what we're working with. So we're starting to see the galaxy. It's starting to really be there. So now that we've brightened that up, the background is a little bit lighter than I like, but we can definitely see the galaxy now. So next I do another round of generalized hyperbolic stretch. I've set the settings, and now we're starting to, I've really increased the contrast without increasing the background too much. So the background is a little bit bright, sure, but now our galaxy is really starting to pop there. As you can see, M109 is really coming out right there. So I run it at about that power and continue on. So now we have this. All right. Now, once you've stretched a little bit, you're going to see that noise starting to come back through. And here is where I usually run another round of our favorite NoiseXTerminator. But usually I run it a little bit softer here. So here I just, even on my RGB, the noise is there, but it's not too bad. But it's definitely there. And I want to bring that down a little bit. So I run it at 0.4. And so let's zoom in here and do a comparison, especially in the galaxy itself. You can see the noise kind of overtaking some of the detail there. And once you run NoiseXTerminator, again, like before, when we saw I used NoiseXTerminator, it just sort of cleans that up, makes it smoother, makes it the noise a lot less, and it'll make the histogram look a little better when we need to move the black point again. So, NoiseXTerminator, great thing. Use it in small increments, and it'll reward you. So now that we run NoiseXTerminator, again, I do the same process that I did before, where we have this histogram, and you have the peak. Again, because of NoiseXTerminator, it made that peak more like this. It sharpens it down so that we can again move the black point in and again increase our dynamic range. So let's see, I think I have this pointed at the wrong one. Yeah, I want 12E. Boom. Okay, so now that we have it there, see our peak is over at about the 1/8 in, about 10-15% of the way in. And I just move the black point into about there to move that peak over, just to buy back some of that dynamic range. And it also yields the darker, cleaner background. So, all right. So our RGB is starting to look pretty good. I like the background. I like the galaxy. I do one last little bit of curves here. I open up curves transformation. It's another thing that you can use to stretch, and this is a very powerful tool that can act really weird depending on where you put these dots. But once you have used it a few times and get comfortable with how these curves work, it's pretty cool. You can use the curves transformation, and you can, if you hold down your mouse button, you can see where these pixels are in curves transformation. You see those little lines moving around. That's roughly where those pixels are. And so I put these points more or less around where those pixels are, just because I want to make the background darker and our object lighter. And so you can see the difference it made. So it reduced the background. Here in Winter Park, the light pollution is pretty bad. I have no hope of really ever getting the IFN, as Frank and I asked Charles Bracken last week. I'm not going to realistically get it without dozens and dozens of hours of integration time. So I usually make my background of my images darker than other people. If you're in a much lower border, a lot less light pollution, people tend to leave it a little bit lighter because space isn't black. But in my case, it just generally, I find it looks a little bit better the darker it is, because the light pollution prevents me from really ever having anything there. So in this case, I've made it nice and dark, brightened up my galaxy a little bit here, and I really like how that ended up turning out. So this is where we now more or less move on from RGB. Our RGB starless image here, that's looking pretty good. I like what we've got going on here, especially considering the moon that we had. It's not looking too bad. So I now set that aside and we go back to our luminance file. This is the L. This is our luminance data. And several of the steps that I do in this case, are very similar to what we do in RGB. So we start with, this is the one that we've removed the gradient from. That's our nice galaxy here. We then run BlurXTerminator on it. And that tightens up the details. I'll show you the comparison. This is the one with BlurXTerminator, and this is not yet. As you can see, it really tightened up a lot of the details here, especially the nebulosity that you can see in the arms of the galaxy. It just made those a lot, exterminated the blur. Hashtag BlurXTerminator. So we run BlurXTerminator. We run NoiseXTerminator next. And again, I think I ran this, I ran it at 50 on this preview image here. And because the noise wasn't too bad, but it's still there. And that yields our much less noisy image. And NoiseXTerminator does just a really good job of removing the noise while not bothering the details too much. So you can see that like the details within the galaxy here are still pretty good, and the noise is vastly reduced. And then, just like we did with RGB, except we don't have to do the SCNR and the saturation, we can just move straight to StarXTerminator. We've now removed the stars from the luminous image. So it's like boom, 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 BlurXTerminator, NoiseXTerminator, and then StarXTerminator. We can just do all three of those right in a row, and that leaves us with our luminance stars that I put over here to the side. Just keep those over there for safekeeping. And our starless image here. And then you can see the flare from Fecta really a lot better without the stars there. So it's really quite prominent there now. And you can see it like the detail difference too of the luminance data versus the RGB, which is why we do that, because the luminance, you gather all of this light a lot faster and you get that detail a lot faster using the luminance filter rather than doing just the RGB. It's like a faster way of getting the detail rather than trying to get it all through the color filters. So once we've done that, now we can do the something we did on RGB. I go ahead and move my black point. The first thing I do once I've done the starless, because we have this you can click this thing right here, auto zero shadows, and that will automatically move the black point into the point where you haven't clipped any data. We've maximized the amount of dynamic range that we've got here without losing any data. So I just automatically do that. It's a quick thing you do. You open that up, you click that, and it automatically moves that to where it's supposed to be. Oh, I think I've got this again pointed at the wrong one. L step 15. There you go. You can't really see it. Here's the peak, but to see this gap here, all that is empty space on the histogram. So we do that, and it automatically zeroes out all of those shadows, leaving a image that doesn't look any different, but it's now got a higher dynamic range than we had before. So next, now we move on to stretching. We can get straight to stretching with this. And again, I use the generalized hyperbolic stretch to do it in 2 or 3 different steps. We can turn off the screen transfer function here so to see what it's actually doing. And then, as you can see, again, my first stretch around 9 and around 4, that's in the case of this data, you can just start to see it. And that's where I stop. I do it until I can just barely see it. And then do level 5. So here's our one that we just did a very minor stretch on. You can just barely see it. And then I reset everything and go again with a local intensity of about 5, the multi-step process. And as you can see, hitting it with 5 at about that much really starts bringing it out without brightening up the background too much or blowing out the core. That's why I do the multi-step thing, because I try not to blow out the core. It's very easy to do that in bright galaxies where the core is the brightest part, but you want to get the dimness, the faint stuff in the edges. So that's why I do that. So that now leaves us with this guy. So we've stretched it a couple times, and now I investigate the noise. The noise isn't too bad, but it's definitely starting to show up in like the edges of the galaxy here. You can see some of that. So I did a very, very light noise reduction of 0.4, and just to clean it up a little bit. See, it didn't really do much, but it definitely has that cleaner look now. As you can compare what you can see in the arms. Just cleans it up a little bit, smooths it out just a little bit. Not too bad. NoiseXTerminator, great stuff. Once you've run NoiseXTerminator, we can again investigate the black point. We can see how much it's moved. Do we need to move it again? Cool. So NoiseXTerminator, again, it made that peak instead of a lot thicker, it made it thinner, and now we can move the black point in again. And in this case, I moved it in. I haven't, it's not completely zero. If it was completely zero, it wouldn't have moved much at all. But again, anything to the left of this peak, more or less is empty data. So I want to increase our dynamic range as much as I can. I moved it to about there, which only, it zeroed out 0.01% of our pixels. That's not a big deal. But as you can see, it darkens that background quite a bit, and it makes the details of the faint stuff pop a whole lot. So that's why we move that black point, and we end up with this guy. And last, I do one more generalized hyperbolic stretch to finally really brighten the bright parts of our galaxy here. As you can see, I do it at about power of a local intensity of about 3 with varying amounts of power. You know, I fiddled with it until it looked good. And now we've got a galaxy that really starts to stand out from that background. And we end up with this. Okay. One last round of curves, like what I did with RGB. I figured out that's about where the background is, as you can see on the curves transformation here, and I do one last little contrast hit with curves. Just to darken that background a little bit and increase the contrast in the galaxy just a little bit. It's a very soft touch, but it made it pop a little bit more. So we were left with a mostly stretched image. Pretty happy with how the luminance is looking so far. Okay, here's where I do something that I think differs from a little bit. We're getting ready to sharpen our luminance data here, and so we already sharpened it with BlurXTerminator. That already sharpened it a fair bit, but now that it's stretched, we can sharpen it a little bit more. So we sharpen using unsharp mask, and I also use MLT, multilinear transformation. I can't explain how this one works really well, other than these are some settings I found online on how to sharpen using it. So there are it divides it into like multi layers of detail. That's generally how I understand it. And then you can change the bias, which is the same as sharpening. Maybe Frank can explain this one just a little bit better than I can. But if you increase this value, it's sharpening. And if you decrease this value, if it's negative, it's noise reduction. So in this case, I've got it set to 0.1, so that sharpens a little bit.
It's not too different from Registax, right? Like it's kind of the same idea of doing
Like wavelets.
Yeah. I mean, it's not wavelets, but like the concept of having different levels of detail that you're sharpening independently.
Yeah, like single pixel detail, 2 pixel detail for like the bigger chunks of layers of detail. Yeah.
Right.
And so in this case, I just add just a little bit of sharpening there, but I'll get to that in a second. So I've got this image. It's pre-sharpening, and I make 3 copies of it. using this thing. It's a duplicate image. So I boom, boom, boom. I have now 4 copies. I have my original, and then I have 3 other copies. I rename one to mask, I rename one to USM, and I rename one to MLT based on what I'm going to do to each one. So I'll actually close these because I already have them open. So I've got my original here, and I make one my mask. Similar to what I did before, I use the curves transformation. That's more or less what it looks like to run it on that, and that yields an image that sort of looks like this, because this is the area of the image we actually want to sharpen. So we want to make this mask so that unsharp mask and multi-layer transformation only sharpen what we want. We don't want to sharpen the background back there. That just adds noise. So we only want to sharpen the stuff that looks like stuff, like the object that we're taking an image of. So here we've got our mask. One of our other copies, I use unsharp mask on with those settings. These settings will vary based on taste. You know, I sharpen this image using unsharp mask. This is the actual already sharpened one. Looks pretty good, but it looks a little crusty in some places. And it sort of varies. I have messed with this time and again, trying various different things, but I almost always settle on a value of around 5.2 there. But again, this is you play with this one, this value here, this slider here, to taste. I set a preview window and then I mess with that and go from there. And then multi-linear transformation, multi-scale linear transformation. I do the same thing on one of the other copies. The 4th copy that I made, I run this on that. And again, it sharpens it a little bit, leaves it a little bit crusty looking, but we'll take care of that in a second. So now, again, what I was talking about with it's a little bit strange. I have my original here. I have my mask that I don't really need anymore because I used that on the other 2 here. So I've got my original, and I've got the unsharp mask version, and I use the MLT version that I've sharpened. I now use pixel math to blend those together because the original looks good, the unsharp mask looks pretty good, but it's a little crusty, and the MLT looks a little bit looks pretty good, but it's a little bit noisy. So I blend those together using pixel math, 30% of the original and then 35% from each of the other ones. Pixel math is a weird little process to use, and it boils an image down to the actual pixel data. Like if you can see here, this actual pixel has a value of 0.0413. So each pixel has its own little value, and you can use pixel math to essentially manipulate those in some weird ways. So this particular pixel, like this one here, is 0.0289. I take 30% of that and then 35% from the other 2 to yield my final sharpened image that just looks pretty sharp, but not too crusty because I've used 30% of the original. And I usually quite like how sharp that ends up looking. We've got some detail here around the core, something like one of those little dust lanes around there. The nebulosity is starting to has gotten a little sharper, and we haven't increased in the noise in the background because we used the masks to blend those together. So we're looking pretty good here. Now I've got my luminance file nice and sharp. Sometimes, I don't always do this, but in this case I did one last hit of NoiseXTerminator because I think I looked at the edges of the image here. Yeah, along here. Sharpening does add a little bit of noise, so I do one last very soft hit of NoiseXTerminator on it, leaving us with a pretty good looking luminance file. So that pretty much does it for my luminance. Now, in this case, in my case here, I showed this to my wife, and I am red-green colorblind, and I didn't notice that we've got a little bit of purple in here. That's the first thing my wife said is like, oh, well, there's some purple there. I didn't know, but she told me that, so that's why I came back to this one and added this as another step. So in order to remove some of that purple, we can invert. Remember, that was something that Charles Bracken mentioned. If you have if you have green, you can use SCNR to remove that. Or if you have purple, you can flip it. You can use invert, and that will leave green where the purple was. And we can use SCNR on the inverted image to remove that purple. Because just like green, there's really not a whole lot of purple up in space. So if you have purple left over, which is very common in narrowband imaging, you can reduce that using something like this. So I've done that. I inverted, I ran SCNR, and I inverted back and ran a little bit more saturation on it to produce a mostly yellow gold core with mostly blue arms, which is much more. Once I did it, I noticed that, like, oh yeah, that color looks a bit better. So now we have a finished RGB. We have our finished luminance. We are ready to combine those into our final thing. Let's see, where is LRGB combine? I'm pretty sure is the, yeah, LRGB combination. So in this case, you uncheck RGB, you select the luminance file, it's usually one of these, and then you drag that onto your color image, and that will apply your luminance detail layer, the detail of the galaxy you just finished working on. You've sharpened it, it looks all nice and stuff, and it applies the color of the RGB image. And so now we have a nice looking starless LRGB image. It's got the detail of the L, the color of the RGB. Looking pretty good. Even the detail, there's actually a little bit of detail in these like background fuzzies with some stuff going on. All right, we have combined our LRGB starless image. Now we're ready to go back over to our stars. Here's where I think some people, I have seen people only stretch the RGB and they sort of just toss their L image. And that's a mistake I see people do, is because you can see the L on StarXTerminator sometimes removes background galaxies, these little background fuzzies that your 12 to 15 hours of L picked up, whereas the RGB did not. And so you want to stretch both of these, and you do want to use both of these. And so once you've stretched it, I used Generalized Hyperbolic Stretch, and I apply it equally to both of them. So I figure out one, I apply it to that, and then apply it to that. It's just what Frank was asking about earlier. You take that triangle and you just drag it onto there, and you drag it onto there, and then they're both stretched the same. And that made it look a certain, it brightened up the stars a fair bit. I ran curves, again, to stretch it a little bit more. And then I did a saturation to increase the star color. And that left me with my nice looking RGB stars with the, and once I used the LRGB combine, I selected the L stars for this one, applied it to the RGB stars, and it leaves us with a nice star layer with some background galaxies all showing up in there. See these little red fuzzies in the background. Now we have our nice star image. Over here, we have our starless image over here. We're almost done. We're almost there. Last thing we have to do is combine them back together. So you do a pixel math thing. I did not come up with this on my own. This was a Russell Croman thing that is in the documentation for StarXTerminator on how to add them back together. So I just did that. And so in this case, you add your, over on this side, you put your starless image. Over here, you have your stars. Run that, and we are left with a nice finished image of M109 with the stars on there looking all nice and, in my opinion, lovely. I liked the way this one turned out despite my woes with the moon. And in the end, we still have Fecta's contribution over here. And yeah, this is now where you get to play, because you can look around in the image. What did you end up with? Like, oh, that looks pretty good. The detail I got out of M109 with a full moon is not too bad. And all of our little background fuzzies, you have like these little galaxies off in the background, or just fun to explore. Um, and if you're so inclined, you can also annotate. There's a script in the background here in the image analysis. Render. It's under render, annotate image. You can run that, mess around with the settings and stuff, and it will label the stuff that's in the image. You can see these background things like, oh, that's GGC 37553, and read about these things and learn things, and like, oh, I didn't even know that was there. In one of my images last year, I discovered a little tiny planetary nebula that I didn't even know was there, because it was this tiny blue ball. And then once it got labeled using this annotator, it was like, oh, sure enough, there's a little blue ball there. I hadn't noticed that it was there during the processing. So that was a cool thing. So you can see things in the background of your images that you didn't know were there, and that's one of the fun things.
Is that kind of like the same software that the ZW ASI Air uses?
I would imagine if the ASI Air annotates, if it labels those like this on the app, then I would imagine it's similar, because this is using remember when we solved the image, we figured out like the exact coordinates of the image, so that PixInsight knew the exact coordinates of the center and the corners and stuff. It applies that information to where known objects are, and based on the focal length of your image, like what the pixel scale is, it can figure out exactly where these things are, so it can circle them. Like that circle is bang on that little galaxy there. M109 is perfectly circled this little galaxy. So I would imagine it's this. If it's not, I'm sure it's not the same software, because this is PixInsight and ZWO has their own thing, but it's the same process. It's the same idea that like the known objects have coordinates that are known, and it applies that into an image that the ASI Air knows that you have based on the settings of the equipment that you have. And that pretty much brings that to an end. We're left here with in my opinion, a very nice little image of M109. I liked the way that this one ended up turning out. And I think I say that about every single image I make, is that when you first look at the image that you start with, like this is the L, when you first look at this, I always have that feeling of, well, this didn't turn quite, this isn't what I expected, but okay, I'll work with it. And then once I'm done, almost every single time, I'm like, oh yeah, okay, I'm satisfied with that. Given the circumstances, given the weather that we had, given the moon that's always there, given the light pollution that we have, I'll take this. I'm pretty happy with it. And yeah, so there you go.
Awesome stuff. Thank you. So, is there anything you do to make it like social media friendly at this point? Do you crop it to a certain dimension or rotate it to be more artistic? Like, is there more to it after this?
Sometimes, yeah. I am by no means a social media person by any means. So I usually turn to my sister for that sort of thing. But yeah, sometimes I do. Like my M63 that I had during the meeting last week, it was this orientation. And so what you can do is I set a preview around it. So, Alt N, or using the preview thing, new preview, and that'll do the same thing. Select the area that you want, and then that leaves your preview thing over here. You can actually click and drag this tab off, and now I have a new image. I have that cropped image to exactly where I wanted it. And then you can go to image here, I think it's called geometry. Yeah, geometry, and then rotate it how you want. So if you want it pointing the other way, you can have it that way. You can rotate it which way you want, whatever artistic way that you want to do it. So that's what I did with M63. It was sideways in my original image, how I captured it. And so I did that. I cropped it and then rotated it so that it was the same way everybody always displays M63.
Right, right. Another thing I want to call out is, this is not a recipe. Like you do not follow these same steps for every image. Like you're making choices at every stage and saying, okay, here's the problem I want to attack, and here's how I'm going to attack it, right? It's not just,
Exactly.
yeah.
Exactly. Like generally there are a lot of steps that you always want to do. You always want to do the color calibration. You always want to do the BlurXTerminator. You have to stretch, otherwise you can't see the image. So there are those things you always have to do, but there are variations in how you do them. Like what I was doing with like the generalized hyperbolic stretch. These exact values are not going to be the same every time. I fiddle with them until it looks right, and then like okay, I apply that, and then I do it again. So there's going to be a lot of fiddling with sliders, a lot of variation to it. I might not always run NoiseXTerminator after the stretch. Might not need to. In this case, I thought it looked nice. I always sort of play with it and see what the end result ended up looking like. And in this case, I ran NoiseXTerminator there. I don't always. So it kind of depends. Whenever I start to see the noise start to flare up, I throw a soft hit of that on there just to keep things smooth as I'm working through it.
Yep. And do you ever find like the next day that you look at the image and say, oh my gosh, I should have done this differently, and like kind of go
Always.
back? Yeah.
Always.
Yep.
And it's just the worst. We're always just like any writer or any artist or anything. I am by no means an artist, but like this does bring out that side of me, I guess you would say. But we're our own worst critic. I can always see like the things I screwed up in every single one of my images. One of my favorite images that I've done of a close up of the center of the Soul Nebula, I had a minor problem with the flats on my O3. And if you look closely, if you really discern, there's a slight little circle in the middle of that image that's a little less blue than the rest of it. And like, that's all I can see sometimes when I look at that image. I know nobody else sees it, but absolutely. And then like, let's say, Russell Croman comes out with like Sharpen Exterminator or Stretch Exterminator, something like that.
Mhm.
That makes us want to go back and reprocess these images. I keep all of my data. I have like a couple hard drives full of data. I keep everything that I've ever done just in case like I have some new tool that's come along. Like Graxpert. Graxpert was a great addition to our tool set. Like it really makes it easy to remove gradients. And so I went back and reprocessed several of my images a couple months ago that I did my very first year. And it's remarkable the difference in quality of the image. Like the data was pretty good. Even in my first year, the data looked pretty okay, but my processing skills were terrible because I was just learning how to do PixInsight and making everything crunchy, over reducing the noise. And my version of them now is just like worlds ahead using the same data. So
Yeah.
Never delete anything is another recommendation I would have.
Yep. Stretch Exterminator. I bet that is next, come to think of
I
it.
hope so. That would be
That's a
so
good
cool. Because I had like, 7 steps to stretching. I'm like, oh, that's the next one.
Yep. Cool. Yeah, if anyone else has any last questions, feel free to chime in. But I'm also curious about that step where you combine different types of sharpening in the end. Is
Yeah.
that something you came up with? Because I've never seen that before.
I found a guy that did that a couple years ago. Maybe Chaotic Nebula might have been the name of his website, and I thought it looked pretty good. The result is because when you use Unsharp Mask or you use MLT to sharpen, it leaves little bits of it looking a little crunchy. Like you sharpen and like some part of it looks pretty good, but some of the other parts don't. And I found that like blending those, using that blending method, makes it end up looking pretty okay. Like the sharpened parts look pretty good without over introducing noise in the parts that you don't want it to. So I've used that for like a couple years now, and I have yet to find a better process for sharpening that looks as good as that. I am super open to finding the very best tool. In this case, I am Borg. I will assimilate whatever the next best thing is. If I find that works better, then I'm happy to use that. I don't care about the process. I care about whatever yields the best results. So I look forward to seeing what some of the others in our group do as far as some of these steps go, and hopefully lift some of those ideas and apply it to my own thing. Because that's one of those things is like you don't know where to start with this sort of thing. Like I told you, like I mentioned in the very beginning, like this list of processes, none of that is here for you to play with. You don't know what order to go in unless you like research from somebody else. Like, what are they doing? Like, how do you like the very first time I downloaded some data from Telescope Live, the process I used was like, okay, well, I stretched it. Now what? I just didn't know what to do. So it just takes some time and effort to learn how to do these things, learn what does what. And then once you are given a fish and eat a fish a couple of times, you start to learn how to fish and how to make each process your own and add your own flair to each bit and realize like, oh, like I liked how that guy did this, but I liked how that guy did that. And it's fun.
Wes, would you recommend the Atom Block videos on how to do PixInsight over anyone else?
Absolutely. I didn't actually subscribe to him. I mostly just used his free videos because he's got a lot of good, useful stuff. If you want to watch like a lot longer video just about any of these processes, like WBPP, the script that you stack images with, he's got some very, very long videos about it where he explains every single little setting, and he does a good job. And you will learn a lot, but they're long videos. But if you like knowing how everything works, if you like that sort of thing, which I do, then yeah, Atom Block is a fantastic resource, and I highly recommend any video that he puts out. I can't attest to the quality of the stuff that you pay for from his site because I didn't actually subscribe to that. I just used his free stuff on YouTube. But if that quality is any indication, then it's probably worth it, especially for the beginner. Yeah, Atom Block stuff is fantastic.
He's also my hero because he figured out a way to make a living off of
Right?
astrophotography.
Yes, exactly.
Nicely played, Atom Block. Any last questions? Feel free to come off of mute if you want to say anything. And if not, we'll close things up soon. But yeah, I think I'll go ahead, Bob.
Oh no, I was just gonna say thank you for doing it.
You're welcome. I hope that it was helpful to people. I hope that I didn't get too long-winded, and I hope I didn't go too fast and provided like enough detail in places, because I know an hour and a half, it took me longer than that to actually just process that this whole image. And so I know that there's a lot of steps. I know that it's pretty detailed, but I hope that it was helpful.
If it's too long, I'll just BlurXTerminate stuff out of it. It's
exactly
fine.
right. Run BlurXTerminator on this video, and it'll fix everything. Yeah, nicely played. So I will provide at some point, probably not tonight, but at some point I'll provide the resources, these repositories that you have to add in order to get like a BlurXTerminator and some of the other tools that don't come in here by default. And I'll also provide these process icons. This is actually a file I can I load load process icons. It's just like this file here. I can make this file available to give people to give you guys like sort of that starting point that you can see like, these are the processes that I used, and then you can sort of start playing with stuff. You can see like that's the crop, that's GragSpert, that's linear fit, like you can sort of see the order that they go in too, because that's the thing that when we start out with this, we don't know what is a workflow in astrophotography. Like what do we do? What order do we do them in? What steps do we do? So like having a good jump off point with some of this stuff is great. But again, this is for mono. If you're using a color camera, you could probably get away with just using this side. There are ways you can lift the luminance off of RGB images and do the same sort of process. But I'll leave that to Frank or someone else to do like the one-shot color PixInsight process. I'll let them show their workflow so that I can learn something about that too. But
I'm also a mono guy, but
yeah,
maybe John. Yeah. Cool. Looks like Will wants to talk a little bit about some gear recommendations. If you got a few minutes, if you want to hang out a little bit afterward.
Yeah, I am happy to nerd about this.
Cool.
As much as anybody wants. I am all about this.
All right. Well, we'll stay online for you here, but for everyone else, if we're out of questions, we can wrap up the tutorial portion of the evening. Thank you everyone for joining us tonight, and thank you so much, Wes Klehm, for doing this tonight. Really appreciate you donating your time tonight. Yeah,
it was fun.
Yeah, I learned a few things for sure. And yeah, we should all do a little walkthrough of our own processes because we all do it differently. That's my main learning tonight.
Yeah.
You are way more meticulous than I am for sure. I'm just like histogram transform done. It's good.
Boom. Yeah, hit it with a hammer.
Yeah, exactly. All right. Thanks everyone. I'll see you next time. And I'm going to stop the recording and we'll just kind of go into chit chat mode here if you want to hang out.
Sounds good.